So, I just did my thing on the future, and now you guys are also from the future, which is nice to know. So what we're going to do first is introduce all these fine fellows. I actually have my uniform at home, so I left that, but I feel slightly underdressed. But what we're trying to do is we're trying to talk about what you guys do, which is particularly interesting because it relates to what I was talking about in terms of hardware in order to change software. These are systems that work with this current technology that we have. It's very easy to retrofit all that stuff to what we need to do. So why don't we start with you, Mariusz? Introduce yourself, explain why you're dressed like that, and what you have to offer us.
Okay, cool. Welcome, all of us. First of all, my name is Mariusz Chmielewski. As you can see, I'm a military, an officer from Polish Armed Forces. And I'm a PhD in Military University of Technology, Cybernetics faculty. And this year, I was a mentor of one of the teams that have joined and actually won the Imaging Cup in Poland. And we have been developing for several months a device with a software which enables us to detect landmines. Actually, the software detects magnetic field distortions, and actually that because of our military background, we wanted to apply this knowledge in terms of helping people with unexploded ordnances.
So to be clear, this isn't a metal detector. This is actually, you can see the object in the ground, what the shape is, where it is.
Yeah. This is a metal detector, and as many of you know that those kinds of applications are already in the market. But our software combines different fields of knowledge in order to, first of all, fuse the information from different sources. We have an accelerometer, electronic gyroscope, magnetometer, of course, and fuse them into one information flow in order to collect and scan the object or ground, detecting or creating image of magnetic field.
Did you guys have any photos of this thing that you wanted to show? Do you have any
this is actually the hardware, if you could.
I guess, can we get a thing on there?
Yeah, I know it's a bit small. And this is actually the application, mobile application running on Windows Phone. And you can see that I've already connected to the device and I'm sensing the magnetic field. You will see it in a moment. Okay, this is the magnetic field around the device.
Now, are you sure you want to run a sapping system on Windows Phone? You're going to get a blue screen of death.
It was mandatory. Of course.
Really?
It
Windows
was mandatory because of the
nobody ever gets fired
theme
for
of the. Yeah, we already ported the application towards the Android devices, and we will be showing this equipment in several conferences and exhibitions. So. Actually, now the project have moved to another level. I mean, we have been developing new types of algorithms, hardware to detect and to make the detection very precise.
But you could also feasibly just use your phone as a metal detector.
This was the initial idea: turn the smartphone into a minefield detector,
which is pretty badass.
Yeah.
Right. So what are you up to, Łukasz?
My name is Łukasz Miądowicz. I'm the CEO of Around company, and we are a strong R&D startup that's making hardware and software solutions. The company was co-founded by PhDs and PhD candidates, so we have a strong scientific field in doing our products. You can see on my head a device that we are using to a system. We combine augmented reality and biofeedback and
neurotechnology. Stand up and show them this thing. It looks like one of the things from Prometheus.
Yeah.
Don't worry about it.
It's too much stuff on my head. So
I have that problem all the time.
Yeah, our vision. Our vision is to combine augmented reality with biofeedback and neurotechnology to control the virtual content that you can see in a real environment by human thoughts. And we did a prototype that we showed at Intel Global Challenge last year that can solve this kind of solution. And we want to combine it with also head-mounted displays and so on.
Okay, and what are you guys working on? Sebastian? I got you guys here. You're here. Sebastian, Christian, I called you out. So what do you guys work on? You guys are together.
Well, my name is Sebastian Heise, and this is my friend, colleague, partner, ex-colleague, whatever. We have a history already. So this is Christian, and we are the co-founders of...
All right. You guys want to sit together, closer together? Is that how that works?
Yeah, actually, accidentally it happened that...
Don't worry. Well, you guys can be apart for a couple minutes.
We're just not that close, so... We are just starting up our company. It's called Graph Masters, and we are doing traffic management. I also mentored a team at the Imagine Cup, and we also won on international level in Sydney this year. We came up with a solution for traffic management that solves some of the hardest traffic management problems that are known for decades. Because it is nowadays possible to use cloud computing technology, and we are sitting on nearly infinite computational power. We have infinite memory, infinite computers that we can put on a single problem to solve, and we use all these computers to, distribute traffic ideally on the streets, and what we need for that is just, we leverage all the smartphones, all the GPS sensors that probably most of you carry all along with you, and just take one single piece, or just one tiny piece of information out of it. It's just your GPS position and your destination. And this is all what we need. We do not need any Facebook accounts or personal data, year of birth, or all that. We are definitely not interested in that. We are not storing data or analyzing big data stuff. We are just computing in a very, very large scale. And distribute all of you, if you want to, on the streets, totally ideally. And everyone can get a personal, individual route from A to B. So even if two of you guys would start here and want to go to the airport, probably you get two different routes from us because, we distribute traffic on streets so that everyone has enough.
So you guys
space.
are actually controlling the traffic. So then we never have to meet, and then we never crash or whatever.
Sorry?
So you control the traffic. So if we both are going to the airport, you know that 5,000 people are going to the airport. So you're going to send one guy this way, one guy that way.
Yeah.
And now in every movie you see like Jason Bourne or James Bond is being watched from like a predator drone, and they always know where he is, like walking around the city.
Yeah.
Do you have that ability, and can we use that on somebody that I know?
Well, maybe you should ask one of these guys.
Yeah, maybe this guy. He's got the ordnance. You've got the software. I think this is.
I have no knowledge about this fact.
All right, and Jakub,
actually, I think we can do that for you.
Yeah, I know you can. I bet you can.
My name is Jakub. I was the co-founder of Ateli, which was the self-service advertising network, very popular here in Poland, sold to Agora, a leading media group. And I was served there for 4 years as a member of the board and the head of product. And in the beginning of this year, I stepped down and I decided to do something completely new, something I've never done before. So probably I can do it. So I decided to co-found a hardware startup. It's called STMode. It's a kind of Internet of Things related project. We are building small devices, small sensors that interact with the physical spaces and put the data to the cloud, and you can interact with the data. So project is currently in private beta, so we are not public yet. And also I'm involved, I'm the co-founder of Material Nation, which is a 3D printing community down in Krakow. You have shown us the MakerBot. We have several of these kind of machines in Krakow, and trying to leverage how we could build a value on top of that. I mean, a kind of in terms of building a community of designers, or people that building their own printers. So this kind of, it's funny because for the last 12 years I was only in software, and I decided to do something completely new, purely hardware product stuff.
So that leads into the next question. I guess, as I said before, in the past 5 years, 5 years ago, you guys probably wouldn't have been able to do that. You wouldn't have had that technology. You wouldn't be able to do a hardware startup. What has changed for you guys, specifically in the past 5 years, that have made it considerably easy to make the things that you make? So you want to go, Mariusz?
Okay, sensors.
Mm-hmm.
Sensors, first of all, sensors. So those devices are pretty available in any device. All of us are using smartphones for everyday activity. And of course, the connectivity issues. I mean, services towards the GSM, GPS, location. Of course, internalization of application is also a critical aspect that is going to take place in a few years. And another issue, I think it's crucial for us, is the availability of technology and the ability of designing the technology and do it by yourself. Because any of those devices I have shown today are made by ourselves, so it's pretty easy to design them and to develop them.
So this is is this an Arduino board, or what are you guys using in terms of sensing?
Sensors are, of course, both, because those are very large-scale devices, but the PCBs and other elements of those boards are, of course, handmade. Let's call it that. So
you went there and you sat there with little tweezers and put all the things
not
down?
me, personally, one of our colleagues.
That poor guy.
Exactly. Yeah, that poor guy.
Yeah.
Exactly.
All right. And what's changed for you in the past 5 years, I guess, in terms of hardware? Why did you pop out of academia and decide to do this?
We decided to do this because in academia we are only focused on quantum physics, so you know.
So am I. It's difficult.
And we have some concepts, and I liked augmented reality as a technology, but I think that we must push this technology by providing the hardware devices and so on. So we are now working on our own hardware for EEG, but also for augmented reality. And I think that the main point that we need now is a big infrastructure for this kind of technologies that are going on in the cloud and so on. GPS, it's not so accurate, for example, and we are interested in UWB technology, and so that's what we are working on now. And so we want to do a better device because we have a product that is called Neuron Input, and Neuron Input enables disabled people to control the computer using their thoughts and muscle tensions of the face. So I see this device that it's quite accurate. The accuracy is 80%, but we want to push it to another level. So
would you guys be doing your own hardware then, or would you still be using off the shelf? Because that thing, that's almost a game device, and it's for test purposes. But you could feasibly build your own hardware.
Yeah, we are planning to build our own hardware, our headphones. That's I think in the next couple of year or maybe something like this will show you the prototypes. And now we are building software that uses this hardware to control the computer. We did some tests, for example, to control smartphones and so on, because often you have a smartphone in your pocket and you have a call, so you need to find it somewhere. And if you have an interface that allows you to think about answering the call, it's somewhere. It's better than Siri, I think.
Mm-hmm. And at what point do we put those huge spikes into the back of our heads, like in The Matrix? Remember that? When do we do that? Is that next year, 2 years?
I think we did some prototype software that enables you to see the virtual content, the virtual models, virtual instructions. We did it at Intel. global challenge, and we controlled this content, virtual content settled in the real environment by thoughts. So we moved, virtual models, using only the power of our brain.
So we don't need spikes in our heads just yet.
You have now a system. There was a paper in Nature about 3 months ago about the ECOG is a technology. So you put a chip on a brain surface, and you have a power arm connected to this device, to this chip, so it can enable disabled people with multiple sclerosis to have a drink or do something else.
You can just do that at home, right?
Yeah.
On the surface of the brain.
I don't
just drill.
Yeah, no. It's a medical, scientific project. So it's not commercial now.
Sony's not making it.
No.
All right. The past 5 years, what has helped you guys work better, especially with all your data? I mean, you're sifting through lots and lots of data, correct?
Yeah. Basically, we started 5 years ago, and back then it was hardly possible at all as some students to handle so much data and to really put this into action. So basically we're talking about almost 1 billion cars that are out there in the world, and this number is increasing. So if you want to route all those cars, and we actually do want to route 10% of them, that means there's an incredible amount of data going on. And what really makes a big difference for the future for me is that we, as a very small startup company, we can handle so many users because we just put everything in the cloud, and with that we can serve as many cars as there are. So there is this possibility for the first time ever to handle such a business with just a few developers and very little overhead. Back in the days, like 5-6 years ago, that was impossible, literally.
So it is not only the one thing for us. It's the whole value chain is tremendously changing. We got new sensors and new hardware on the one hand, and we as just a very small team can reach this huge market directly without any overhead of salesman or something. We simply provide an app in an app store and can reach this huge market directly. But it's again more. Everything is shifting. We can focus on what we can do, and we can buy cloud computers as a service. We do not have to take care about operating systems or maintain computers at all. We just buy something. We can sell something. The engineering at all, research or science changes by these possibilities. Our students can simply just, I have a bachelor thesis to write and I need some 1,000 computers to compute my idea, so no problem, you just get 1,000 computers to compute it or whatever. This is drastically changing science too, and this will lead to a completely new world for me in the next years, because everything's you will get more focused, more small and more focused teams that are highly experienced in a whatever certain part of field. I don't know anything. Maybe design, maybe hardware, maybe I have no clue.
But you're able to build models. You'll be able to build models on almost everything.
Yes.
So you want to build a model of the brain. You can build a model of the brain.
You get many of these small companies or small teams that are highly focused and really good in what they do, and they will drastically drive business, trading, everything. So there will be more change than ever before.
Okay. And Jakub, what did you guys learn over the past? You haven't been doing this for very long, but you just your little thing. We can't talk about it right now because it's really cool, but your little thing's really cool, right?
Yeah, I mean, I remember in early 90s, I was playing computer games like probably most of us, and I was I wished to create similar games or software myself, and it wasn't possible in the beginning, but then I just learned how to download a compiler, how to write software, how to create stuff, and I was proud of it. So this is how I learned to do software. And recently, we can see this kind of new trend that the hardware is new software. It means that producing a prototypes and designing a hardware, it's less and less expensive in terms of how to learn and how to do it. So nowadays you can just, order for 15 euros Arduino board or Raspberry Pi or ARM processors, and even myself, I don't remember the law of Mr. Ohm, but I can plug stuff and build a prototype. I can 3D print a case in cover, and then I can take some pictures, record a video, put it on the Kickstarter, and just validate the concept if people are interested. So I mean, this is a tremendous change in how the creativity of people could lead to new ideas, to validate them, to push them to the market. So I think this is the main kind of power behind such a creative, innovative projects like our.
Okay, and I guess we have got about 10 minutes, so I wanted to get you guys these guys are obviously building teams, they're building projects. Maybe it's a software, maybe it's a hardware piece. What is your best practice? What have you learned in building it? And you can start, Jakub, and we can go backwards. That might be interesting to try. But what's your best piece of advice to somebody who wants to build hardware, who wants to connect software to a sensor, and who wants to build a team to build a product that nobody's ever seen before? I mean, your product's great. Everybody's product is.
Yeah. Well, first of all, I can tell it from the Poland's perspective, and trust me, building a physical device like an electronics module in Poland is far less cheaper than the simplest iOS application. It's very, very cheap. There is plenty talented people down here who you can hire them to program microcontrollers and do the basic stuff. So I think what I have learned since the beginning of this year when I'm involved in this project is I can apply all the methodologies from software like agile, fast iterations, and all that kind of user experience, customer validation, all that stuff. It can be easily applied to designing and developing real physical product. At the end of the day, we all live in this carbon-based world, and probably there is a huge amount of different applications of physical things, interaction between the real world and the real people that are living here. So I think that what you have learned about analytics, what you have learned about agile and project management can easily apply to you have ready mindset to try to do it in a new way. And I think that's my advice.
Okay, and you guys were talking about building teams to do software. So what's your ideal team? What's your advice for people?
The ideal team is a social group that works perfectly that is definitely focused on a certain aspect in technology or whatever they are working on, and they work as a social group. This is important for us. Which is more important than bringing the right experienced or engineers together, than more having a team that can work together, because you have to share the work or distribute the work load every day, and there are so many things. The most expert stuff can be just get from the outside. You just have a network and you ask the right people to get the right informations, but you have to run the right thing, and you must be open-minded to get the right information, and there shouldn't be too many authorities in there or levels in so that everyone can say his opinion and to create the right innovation.
Is that different than the way it was before, I guess, even in the universities or in companies? Has it changed?
Well, this is
I mean, Americans are a bunch of slap-happy jerks, and they're like, "Hey, everybody, we're really happy." But it seems like what you're talking about is you need to move into some sort of like more social, flat hierarchy as opposed to a top-down sort of situation where somebody's controlling every aspect.
I see many teams. They are really, I would say, they have a skizzer in mind. They always cut their ideas already in the first at the very, very first stage was, this is not possible. You can never do this. It's impossible. You shouldn't thought about this thing because this is unchangeable at all. You will never do this. You will never do that. So, and I always try, and this is, well, we actually do this all the time. We definitely try to say, no scissors in mind. Think openly. There will always be at least 3 good solutions for every problem if we just, well, think about it. So if we don't have the solution right now, maybe tomorrow.
Did you have something to add?
Yeah, I totally agree, of course.
Excellent, thank you.
But what's, in my opinion, also the way companies are working at the moment will change drastically. At the moment, if you want to do something big, you need a data center, so you need people to administer stuff. In the future, you can focus very precisely on your skills. So every team has some very core skill where it is very good at. And there is other stuff that obviously needs to be done, and that can be done by other services. And that's I think, a very, very good way, especially for startups, to do interesting stuff.
All right. Anything out of you?
I learned that if you have an idea, just write it on a sheet of paper and just do it. And it works. As you said, we had a Raspberry Pi and so on. This kind of technology is easy to make a prototype really quickly and go to some money to find some financing. But I can say also that we are cooperating in new technologies with, for example, as a technical university, because I'm also a PhD student at a technical university, we are cooperating with, for example, Academy of Arts and building teams that are, they give a content to the technology, so we can push it to other usages and so on. So it's important to have a team with open-minded people, and that's what we've learned to form teams, and we show them methodologies like Agile, as you told, and that's how I see. Because in my company you have 3 crazy engineers that didn't have a business background. We had to learn a lot how to, generate from the technology some products and concept, and it was really hard to us. But we made a step to the future in this kind of in this area. So that's what I learned.
It seems like you guys are the ideal team. He was telling me about Bartek, who's one of their guys.
Yeah.
He's really into trees.
Yeah,
he can also program. He can program a missile, but he can also cuts little pieces of trees and eats them. How does that work?
Yeah, Bartek is a CTO of our company. He's a PhD now in quantum fiber optics.
As you do.
Yeah, and he is a crazy guy. You come to him and say you an idea, and tomorrow you hear a call. I just did a device that is solving your problem. And Bartek, when I call him, for example, he says me, I can't speak because I'm doing something, some kind of cool technology. For example, last day I speak with him, and he told me, Łukasz, I'm working on an algorithm that will combine the virtual world with the real world. Please give me time.
Usually I'm on the toilet when I say that.
And after this, I called to him another day, and he says me, please don't interrupt me because I'm digging digging a hole for my tree because he's fascinating, and he's also a specialist in trees and so on. So we learned also to show people that if you are a computer hardware hacker, geek, and so on, and if you have something that can free your mind, it's really important. So.
Okay. And Mariusz, you're the last guy.
Okay. Key point or key aspect of combining or integrating a team. First of all, in my opinion, there are no cool projects now which are done only by developers. You have to have an interdisciplinary team to come up with ideas, to solve problems, and to envision some aspects of a project that has a meaning for other people, but for developers it's not just a problem or not a key issue. Second of all, you have to find people who are very committed to your project, because actually this project is completely uncommercial. People who have been developing this project are all soldiers, so we have no possibility of selling this project, as I said before. And the things that we have been doing with these projects are the things that we want to show people or to give them as a final project in order to, let's say, make us very proud and, let's say...
well, you're saving lives, essentially.
Exactly. We do not think about this project in terms of commercial applications. This is the initial idea. So, first of all, the commitment, and of course, people who drink a lot of coffee, I think.
Okay, excellent. It's coffee and commitment. Thank you very much, gentlemen. I really appreciate it. This has been a blast. I get to see all kinds of cool stuff, and you got to see all kinds of cool stuff from the future. So I suppose we're done with this one. So thanks a lot. Give these guys a round of applause. They did all this in English.